The purpose of this video is really to help make a connection between a lot of the topics that we've talked about throughout this unit. So we want to connect this whole idea of a limit and an asymptote. So hopefully by now you're okay with the fact that an asymptote is a line that a function approaches but will not cross, with the exception of those horizontal asymptotes that they can cross kind of in the middle, but out at the end behavior they will not be crossed. And vertical asymptotes for sure will never be crossed. So I want to look real quick at this function, 3x squared plus 5x minus 2 over x squared plus 2x minus 8. Well, the first thing to do to find a vertical asymptote, or an end behavior asymptote, which we'll talk about on the next slide, is the same way that you would find a hole, right? And you would start to try to figure out your domain, and it's the first step for all of these rational functions, and that is to simplify if you can. Well, this one is going to factor into x plus 2 and 3x minus 1, and x minus 2 and x plus 4. So from here, we would be able to read our domain, x is not equal to 2 and x is not equal to negative 4. We can also tell that there are no holes to be canceled out. From the fact that our domain is x can't be 2 and x can't be negative 4, and the fact that these don't cancel, that means that there's going to be a vertical asymptote at 2 and at negative 4. Okay? So that means if I were to find the limit as x approaches, we're going to say negative 4 from the left, and the limit as x approaches negative 4 from the right, these are going to be some form of infinity, either positive or negative. Likewise, if I were to find the limit as x goes to 2 from the left, or the limit as x goes to 2 from the right, these are going to be some form of infinity, because we're hitting an asymptote, we're not allowed to cross over it, and then we're going to run to infinity or run to negative infinity. Well, to know which way, we can consider looking at the graph. Okay, so in my graphing calculator, here I have my function. This one I'm going to hit and run to infinity. From the right, I'm going to hit and run to negative infinity. This is infinity, this is negative infinity. The equal signs there. Looking at x equals 2, from the left I'm going to negative infinity, and from the right I'm going to infinity. So when you hit a vertical asymptote on your graph, your limit is going to result in an answer of infinity or negative infinity. End behavior asymptotes. Okay, again, I'm going to sketch in our graph. You already knew that these two vertical asymptotes existed. Okay, end behavior asymptotes help us as we talk about limits at infinity. So here we had the limit as x was approaching a specific value. Okay. And our result was a form of infinity. Limits at infinity, we're going to be looking at infinity that we're approaching, or negative infinity that we're approaching, and we are going to be equal to some number, either the coefficients, 0, or potentially plus or minus infinity if you had a slant asymptote. Well, here, if we think about the limit as x goes to infinity, or finding the end behavior asymptote, both of those things you're going to approach in the same way. Thinking about the heaviness of this function, okay, or the weight, the power, x to the second and x to the second are even heavy, in which case there is a horizontal asymptote at the line y equals 3. Okay. Then, if we use our calculator to help us in graphing some more key features, I know that this is going to look something like this, and like this. Well, the limit as x goes to infinity, my y values are going to converge on 3, and as x goes to negative infinity, my y values are also going to converge on 3. So finding the end behavior asymptote helps us explain the limit at infinity and vice versa. The limit at a point, if you get a form of infinity, that is going to inform you that you have a vertical asymptote. Okay, so limit as x goes to a point, my y values might be going to infinity or negative infinity. As x goes to infinity, my y values are either going to go to a horizontal asymptote or to their end behavior asymptote. Just trying to make a little bit of a connection there for you. The next video and the last video of this unit will have a much bigger analysis of all things dealing with rational functions.